Hello there, this is an Algebra 1 video. It is Chapter 8, Section 9, and it is the last section in this chapter, so that means that you will be having a test coming up very shortly. Today we're going to be discussing perfect squares. We have discussed perfect squares in the past, in the previous lesson, just like in 8-8, we've learned the patterns for products of binomials. But I've put it here again for you. We know that if you have a plus or minus b quantity squared, that it becomes a squared plus or minus 2ab plus b squared. So we know that when we see this, we can factor it like that. But today we're going to try to see if we can go backwards. When we recognize, we're going to try to see if we can recognize this pattern and then write it in this format. And by the way, the plus or minus means that if it's a plus b quantity squared, you're going to get a plus 2ab here. If it's a minus in the parentheses here, you're going to get a minus 2ab. So it says here in example 1, determine whether each trinomial is a perfect square trinomial. Write yes or no, and if it is, they want us to factor it. Well, the first thing we want to look for is, do we have the a squared, b squared? Because we have to identify what a and b are. So we can say pretty safely here that our a could be 2y, because if we square, well, let's just do it here, then a squared would be 2 squared, which is, we would get 2y squared, which would be 4y squared. So all that checks. So our a value could be 2y. And then for our b, we could argue that b is 3, because b squared would equal 3 squared, which would be 9, which is what we have here. Now the only thing that's left to check is the middle term. We have a squared, we have b squared. Does it in fact fit the 2ab? So based on the fact that I already know what a and b are, the question is, what is 2ab? Alright, and because we have a positive here, we're going to assume that we're going to try to get a positive 2ab. So we have 2, our a value is 2y, and our b value is 3. So we go 2 times 2 is 4, times 3 is 12y. So our 2ab factor ends up being 12y, which is in fact the middle term here. So this all fits that it is a perfect square trinomial. So the answer first and foremost is yes. And then when it says to factor it, we write it as a plus b quantity squared. Since we already said that a was 2y and b was 3, then the factored form is 2y plus 3 quantity squared. This is the second part of our answer. Alright, so then we go to part B. We'll do the same thing. We're going to say that a equals 3x, because 3 squared is 9 and x squared is x squared. And then for the b, we're going to claim that b is 2, because 2 squared will give us the 4. And now we have to check the 2ab. So 2 times a, so 2 times 3x, times b, which is 2. And this time 2 times 3 is 6, and 6 times 2 is 12, and we get 12x. But that's not the middle term here. It's negative 6x, not 12x. So in this case, the answer is no, it is not a perfect square trinomial. So the first thing you want to do, your strategy here, is to identify a and b, and then confirm that the middle term is part of the pattern. So we want you to now try this do-it-yourself question, and then we will move on to example 2. It says, factor each polynomial if possible. If the polynomial cannot be factored, write prime. So at this point, we're going to kind of combine everything that we've done in this lesson and use all techniques available to us. But of course, the first thing you want to do is try and see if it's going to fit one of those perfect squares or difference of two squares type situation. So for example, in part A, the first thing you want to do when you're factoring at all is to factor out any common factor. We know that 5 goes into both 5 and 80. So the smart thing to do here, when you first look at this problem, you might be thinking it doesn't fit any of the patterns that we've discussed. But in fact, if you take out the 5 first, then all of a sudden you get a whole different story, because it turns out that 80 divided by 5 is 16. So therefore, we can factor out the 5 in this problem and end up with a beautiful difference of 2 squares, because we can rewrite 16 as 4 squared. And now we know that our A value is x and our B value is the 4. So we're going to get our pattern x minus 4, x plus 4. And now this is our complete factorization. So sometimes you need to take out a common factor before you can recognize the pattern. So in this case, we didn't recognize the pattern here, but when we factor out the 5, then you can see the pattern of the difference of 2 squares and then factor it further. So in part B, we're looking for the same thing. We're trying to see if we can pull anything out. The 9 and the 6 have obviously a 3 in common, but then you have 35, and 35 doesn't have anything in common. So all of these terms don't have any common factor. Therefore, we're not going to be able to use the ax squared plus bx. We're not going to be able to use the perfect square trinomial, but we still have available to us our factoring technique from before. So we're going to go ahead and do that. And so with the 9, we're going to go 3x and 3x. I'm going to try that to get 9x squared. And then with the 35, we're going to go with 7 and 5. Because 7 times 5 is 35. But one of those needs to be negative because it's a negative 35. So I'm going to go ahead and try putting a negative 7 there. And what's going to happen on my diagonals, I'm going to get 3 times 5 is 15x minus 3 times negative 7. And 3 times negative 7 is negative 21. So we're going to add negative 21x. And that equals negative 6x. So I got lucky there, and I made sure that I put the right numbers in there. So our final answer will be 3x minus 7, the top factor above here, and then 3x plus 5. So in this case, we didn't have this polynomial fit any of our patterns, but we can still factor using our previous factoring methods. So that is how you do that. And so now we're going to ask you to do this do-it-yourself question. Remember, the first thing you want to try to do is factor out any common factor to see if you have any of those patterns available to you. So now we're going to solve quadratic equations with this whole factoring idea. So it says solve 9x squared minus 48x equals negative 64. The first thing you have to do is make sure that you equate it to 0. So the fact that it says equal negative 64, we need to bring that 64 to the other side. So we're going to add the 64 to both sides, and that's going to give us 9x squared minus 48x plus 64, and then equal to 0. And now we're going to try and see if we can do any of our methods. I'm looking at this little guy here, and I think that A could equal 3x because 3 squared is 9 and then x squared. And I'm thinking that B could equal 8 because 8 squared is 64. The last thing I need to check, this is a negative, I need to check if I get negative 2 times A times B, if that's going to equate to negative 48x. So negative 2 times 3 is negative 6, and negative 6 times 8 is in fact negative 48. So that means that it does work out. So I don't need to do the factoring technique that I used in the previous example. I can actually use the square of a binomial. So according to that pattern, I just take A minus B, because this is a minus. So I'm going to say A minus B quantity squared equals 0. So now I factored the left-hand side, and I know that it becomes 3x minus 8 quantity squared, which really means 3x minus 8 times 3x minus 8 equals 0. So I get the same factor twice. And now, we know that when we solve with factoring, the first thing you're supposed to do is take each factor and make it equal 0 individually. But in this case, you get the same factor twice. So I only have to do it one time, because each time that I do it, I'm going to get the same answer. So there's no need in having to do it twice. But this is called a repeated factor. It's totally normal. So 3x minus 8 equals 0. So we add 8 to both sides and then divide by 3. And so our answer is going to be x equals 8/3. So we don't write the answer twice, but basically this is a repeated factor. So our solution is x equals 8/3. Alrighty, so now we're going to have you do this do-it-yourself question. And then we're going to go to example 4. And example 4, it says solve each equation, check your solutions. This is one of the situations where you don't actually have to equate the problem to 0. It's very convenient for us sometimes to have a perfect square on the left-hand side of the equation, because then we can use the square root property to solve. So in this case, instead of trying to subtract the 81 to the other side or trying to expand this, because we already have it in this form, it's actually to our benefit in this case to go ahead and take the square root of both sides. And by doing so, the square root and the square will cancel, and you will get y minus 6 equals the square root of 81, which we know to be positive or negative 9. It is very important that you put your plus or minus there, because negative 9 squared is 81 and positive 9 squared is also 81. So you have to keep in mind that it could be either way. So you want to put plus or minus 9. And then we just solve for y by adding 6 to both sides. And so you're going to get two solutions. Either you have positive 9 plus 6, which is 15, or you have negative 9 plus 6, which will give you negative 3. So you have two solutions there, 15 and negative 3. And then we want to go to part B in the same way. The only difference with part B and part A is that in part A, the square root of 81 was a beautiful integer 9. In the case of the 12, we're not going to get, the square root of 12 is not going to be an integer, it's going to be a decimal. So that's going to make it a little bit more complicated for us to simplify, but it's still doable. So what you want to do is you want to break down your 12. 12 is the same thing as 4 and 3. So the square root of 4 times the square root of 3 is the same thing as the square root of 12. And the square root of 4 we know is 2. And the square root of 3 can't be broken down any further. And it's not a perfect square. So we get that the answer is 2 root 3. The square root of 12 is the same thing as 2 root 3. Then we subtract 6. And of course, my bad, I should have put plus or minus in there. And so when I subtract 6, our final answer is going to be negative 6 plus or minus 2 root 3, which literally means that you can leave your answer like this, but that literally means negative 6 plus 2 root 3 is a solution, and also negative 6 minus 2 root 3 is a solution. So if you want to split the two answers like that, you can, but you can also leave it as negative 6 plus or minus 2 root 3. All right, so now I'm going to have you try this little guy, and then we're going to go to our last example. And of course, it's a word problem. It says, during an experiment, a ball is dropped from a height of 205 feet. The formula h equals negative 16t squared plus h sub 0 can be used to approximate the number of seconds t that it takes for the ball to reach a height h from an initial height of h sub 0 in feet. So basically the t is the seconds and this h sub 0 is the initial height. It says now find the time that it takes the ball to reach the ground. So they want us to find the time, so that means they want us to solve for t, and it says that it takes the ball to reach the ground. While the initial height was 205 feet, because that's where it said that it dropped from a height of 205 feet. So we're going to plug in everything that we know. The height of the ground is 0. So therefore, for the h here, we're going to replace h with 0. And then the negative 16, the t is what we're trying to solve. And then it says plus the initial height, plus h sub 0. But the initial height was 205 feet. So this is my equation. 0 equals negative 16t squared plus 205. So now to solve, I'm going to move my 205 to the other side. So it's going to become negative 205 equals negative 16t squared. And then to get rid of the negative 16, I'm going to divide by negative 16 on both sides. And so I'm going to get that t squared equals a positive 205 divided by 16. So I'm going to get a decimal. It's going to equal approximately 12.8125. And then I'm going to square root to get rid of the square on the t. And remember that I'm going to get two solutions. But in this case, because we're talking about real time, it doesn't make sense for us to have negative time. So we're just going to go ahead with the positive solution. So our square root of is approximately 3.5. Does it tell us how far it wants us to round? It does not. 3.579 seconds, or basically 3.6 seconds. All right, so again, remember that we technically get two solutions, positive 3.6 and negative 3.6, but we discard the negative 3.6 because this is a real world application and it doesn't make sense for us to have negative time. So we're going to stick with the positive solution of 3.579 seconds. All right, so now you can try this little guy. It's going to use the same formula but with a different scenario. This time it's dropped from a bridge that is half as high as the one described, so half of the 205. Alrighty, so once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.